We are talking about copper fundamentals today. And again, my name is Thomas Hüsch. Konstantin has already introduced himself, so we can go on with this. So let's see. If we are talking about copper fundamentals, we have first the presentation of Softing. Then we are talking a little bit about structured cabling, twisted pair. And we are talking about performance levels, test equipment and measurement, and about our promotions and other online seminars. And then we will be at an end. Approximately, we will have 45 minutes for that. So let's start with who is Softing. Softing is a stock-held company, so it is publicly traded since the year 2000. Softing is a German company. It is a management holding that is run in accordance with the principles and values of a German medium-sized company. Our headquarters is here in Haar, close to Munich in Germany, and we have a turnover of approximately 90 million euro each year and approximately 400 employees annual average. And we are locally presented by our own employees in a lot of countries like Germany, France, Italy, Austria, Romania, USA, Singapore, Japan, India, and China. This is for the company itself. And Softing is consisting of more or less 3 parts. One of the parts is automotive electronics. They are looking into everything that is in cars. And today we are talking Ethernet in cars as well. In the industrial automation, there we are having another part of this company, and they are looking into products and technologies for the industrial production environment. And we as Softingit Networks, we are in the middle in between these both, and we supply both as well with all the necessary stuff that we need if we are talking about test equipment. And we have test equipment to verify, qualify, and certify copper and fiber optic wirings as well inside of IT systems. So our global offices of Softingit Networks is main office Munich, with some offices around in Europe, in London, Paris, Milano, or Milan, and Vienna. And that sounds more like a company that is making fashion and not as a company that is making industrial test equipment. We have another office in Singapore that is as well our R&D office, with a sales office in Shanghai, and we have an office in Knoxville, Tennessee. There we are covering all of the Americas. So we have this global site that we cover from Munich. We cover the existing parts here in EMEA. From the side of from Singapore, we cover all the Asia Pacific room, and from Knoxville, we do all the Americas. Our test and measurement instruments that we have is, we have certification instruments, we have qualification instruments, verification, and we have something that is named a wireless LAN network sniffer, the Wave Expert, and all this stuff can be found as well in our catalog. So let's look into structured balanced twisted pair cabling. And we are looking today only in office environments. So structured cabling in the office environment can consist up to 3 subsystems. The 3 subsystems are the campus area with the campus backbone cabling. That is the cabling between the buildings, and it is more or less today designed in fiber optic, in single mode and multi-mode, depending on the distances between the buildings. If you have buildings that are not further than 300 meters apart, you can usually run it in multi-mode up to 10 gigabit per fiber. And if that is far more further away, you can take that with single mode, and then you can go up to 1.5 kilometers. Building backbone cabling is the riser or vertical cabling between the floors, and it is usually as well today designed in fiber optic, in multi-mode and single mode. The same applies as in the campus backbone. If you have links that are less than 300 meters, you can use it with single mode, multi-mode, sorry. And when you have links that are longer than 300 meters, you go for single mode fiber. We have an exception in the international standards today as well that allows, if the backbone cabling distances in the building are less than 100 meters, you can use as well copper cabling, but that is an exception. The horizontal cabling today, the floor cabling, is more or less designed in copper and twisted pair. There is an allowance for a second port on each work area that can be done in fiber optics as well. That is something we will talk about tomorrow when we do the fiber optics training. We have that links that we have in the horizontal area with or without consolidation points. That is the possibility to have something there in between. Okay, so let's go on. The copper data cables, the basis of today's copper cabling that is known as twisted pair cables, TP is a short form for twisted pair, contain 8 wires. They are pairwise twisted together to get 4 transmission paths that you can use then. And these 4 transmission paths have in the pairs different twist factors as well. Essentially, there are 2 types. Worldwide seen UTP, formerly known as only UTP cable, unshielded cables is what you find everywhere in the world. And we have as well today shielded cables that are either only one shield around all the pairs or including foils that we have here as well in the presentations that we can use as well. So you have these foils around the single pairs. And what you can clearly see here as well is already that the twist on UTP cables and the twist on STP cables is a little bit different. Usually the STP cables don't need that much twist to keep these cables well. There is a designation today that is done from the standardization, and I have named here the cabling scheme from the ISO IC 11801-1 that has for the overall construction with shield or no shield or foil or braided shield a specific sign in the beginning, and then it starts with elements, screens, foiled or unshielded, and then if you have a twisted pair or a twisted quad. The twisted quad is not that much more used any longer, so that is the reason that we have today here more or less only the SFTP and UUTP cables in practice, but all the other things can be possibly used as well. Copper data cables have some specific parameters. The specific parameters are first the performance range that is expressed as a category. Typically starts with category 5 and goes up today up to category 8.2. The colors on the wires are specified: green, white, blue, white, orange, white, brown, white, but the sheet colors are not standardized. So everyone may have different sheet colors. So there is as well no conclusion about any performance levels by the sheet colors. The conductor diameters are expressed in American wire gauge, AWG, and the typical cables today are American wire gauge 22, 23, and 24 that are commonly used for links up to 90 meters. Especially if you have longer runs that are allowed in the ISO IC, then you may prefer to use a cable that has a larger diameter, and American wire gauge is, the smaller the number is, the thicker the wires are, the conductors are. And if you are talking about American wire gauges that are less than American wire gauge 24, then you have solid conductors for typical home or data center applications with shortened length. So if you have a flat and you want a cable that you don't probably not need full 90 meters. So you can reduce the diameter of the cable by reducing the conductor diameter, but you don't reach the 90 meter anymore. If you have a construction of the conductors that are stranded, then you have typically patch cords that you then see there. So the stranded conductors are typically used for patch cables. The number of wire pairs is usually today for the universal cabling that can support 1, 10, and 40 gigabit Ethernet applications, and in the future probably as well 100. That are 4 pairs that you always use there. 2 wire pairs cabling is done for Ethernet with a maximum speed of 100 megabit. So the application on 10 and 100 megabit run on 2 wire pairs, and that is commonly used still in the industry they are using that for Profinet in example. But they are looking for 4 pairs as well. You may have already seen that there are the M12X coded connectors in place that have the capability of supporting 4 pairs, and that have the capability as well to support 110 and probably as well in the future then 40 gigabit or higher. Then we have a specific new thing that is coming up, that is the one-wire pair, and that is the single pair Ethernet. SPE is the short form of that one, and that is an upcoming cabling for Ethernet, specifically with special specifications for individual applications, and that is based on the speed and on the length requirements. You can go inside of a car and have a single pair Ethernet that may run as well on speeds that are gigabit or higher. Probably as shorter these wires are, the better the communication will be. But if you are looking in the long distance, in example for sensors or other things, then you can have a run as well of up to 1 kilometer. But that is a really special thing in the moment. It's still in development, so that is something that we will see in the future as well. The signal transmission basics for twisted pair cable is different to a coax cable. On a coax cable, you had the center wire there where all the signals were running about, and you had then the screen around that one. On a twisted pair cable, you have balanced signals. They are equal but opposite in the currents. That means you have the transmission from a transmitter that is inverted on one pair and non-inverted on the other pair. So everything that may have an interference will then go into both wires. And that will mean as well that this then at the end, when it's coming to the receiver side, will end up then there with the differential receiver, that it will get out of that one the original signal, even if you had an interference overlay on that one. The opposite fields, that is something that we have on the wires themselves. If you see the currents that are flowing through the wires in one moment, then it may be that one wire has a positive signal, the other one a negative signal, and you have then the current flows inside of the wires and the electrical fields around that one that are balancing it out, nearly perfectly. And that is the reason that we have test equipment, because it is not perfectly the world. So that is exactly the theme that we have then for that, a possibility to test how much of the signal is transmitted between the pairs and whatever happens inside of pairs. The shorter distance from the conductors, the shorter the distance between these conductors is, the shorter the distance is, the better is the impedance and the better is the prevention of external interfering influences. So twisted cables improve the balance and reduce interfering influences as well in both directions, from the pairs to the outside as well as into the pairs from the outside. The connector system that is today one of the most used connector systems is the standard connector for category 3 to category 8.1. 8.1 is a new term that we have here in place since the standard is now going up to 2000 megahertz on an RJ45 connector. And that is all followed by the standards in the IEC 603-7-X, and we will see some more of these numbers on a later slide. What we have here on the left side is we have modules that you can clip into outlet frames, or that you can clip into patch panels. There are still some LSA-based. LSA is the technique to ticker the wires into the connection that you still find outside in the installations, very rarely on the patch panels in between, but on the outlets you still see that. And all of that is then with the RJ45 connector, and there are different types today available, including that you will find some that you can directly mount onto a solid cable to build an MPTL link. Basically, the color schemes for this putting the wires into the right places is today the T568A and B scheme. The A scheme is preferred by the ANSI TER, the B scheme, whoever wants to use it. The further connector systems that we see there are the GG45 and Terra connectors that are standardized as well for category 7, category 7A, and category 8.2 up to 2000 megahertz. And these are special connectors that you will find there and special sockets as well. The sockets on the GG45 from Nexans, an example, has 12 contacts. So we have the standard contacts 1 to 8, and then you have the possibility by plugging in the correct connector into that one, and the correct connector would be then the connector that we see here with a very small plate and the plate on the top here. And this plate here will then push the button on the back side of the socket and will switch the connectors 3, 6, 4, 5 to the edges on the other side of the connector. So we have a 4-quadrant connector at the end that is then isolated in the plug with metal, so that you will find then 4 pairs in the opposite sides of all the connections there. The Terra connector from the company Simon is not looking anything similar like an RJ45. It has approximately the same size, but as well as the GG45, if you plug these connectors together, you will have then at the end the ability to have there a 4-chamber transmission in there. The mother of all 4-chamber connectors is the MMC Pro connector, formerly known as EC7 connector. It is not standardized in the ISO IEC, in the TIA, or in the EN standard, but it is capable of running up to more than 2000 megahertz in the frequency range. So you can use it from class C to class 2 and category 8 and multimedia applications, whatever you want to do there. And the isolation here between the pairs is really, really good. So it is as well a design in there where you can find a 6-pair connector, so that you can still have gigabit Ethernet on 4 pairs, still 1 pair for phone applications and 1 pair for multimedia applications. The individual components become then at the end a link. And the individual components are the cables, the patch panels, the outlets, intermediate connections like cross connects or like the consolidation points. And you have as well in categories the patch cords. Patch cords are all classified into categories as well. And if you put all this stuff together, you will end up with links. And there is a difference between a so-called consolidation point link that goes up to a consolidation point, a permanent link in this case with 3 connectors, because a consolidation point is here in place, and you may have as well a channel link including the cross connect. So you may end up as well up to 3 or sometimes 4 connectors in a channel. So this is a quite nice picture, and we highlight that the source from this for this picture is the company Comscope that we have it from. The other stuff is from the internet. The performance levels that we can see here are mainly categories and classes. Categories are the performance levels of individual components. So the cables, the panels, the outlets, the patch cables, connectors, everything is named categories. So if you have a category 6A connector, you will have that inside of these categories. The classes then are performance levels for cabling links, specifically pursuant to ISO IEC and the following other standards like the EN 5173. And the only exception here is the Americans. The Americans in the ANSI TER standard in the 568.2-D, they have components in there that are classified in categories, and as well they have the links classified in categories. So sometimes people get a little bit confused about this, that you have here the difference between international and European standards that are ISO IEC 11801 following, and then name then all the links then in classes, class D up to class 2, or the Americas that have then links that are classified from category 5E up to category 8, but without category 7 and 7A, because it was something that the Americans did not want to use. The frequency range goes today up to 2000 megahertz if you're talking about category 8 links in the Americans, and as well class 1 and class 2 in the international and European standards. And we, as a manufacturer of test equipment, we had to make sure that our test equipment that we have out there is as well classified in accuracies. The accuracy level 2E is an accuracy that you are using if you want to do a class D link, and the accuracy level 2G is from the TIA standardized, and level 6, 1 and 2 is from the ISO, and as far as I know, still in draft. The link categories and classes versus application is a nice sheet where you could see how all this stuff has improved between the early 90s, 1991 and 1995, and through the 2000 beginnings, and today we are up to class 2, and you can run over that one Ethernet with a speed of 40 gigabase T. So you may be running on links with real high speed, but only with a reduced length of 30 meters. The test and measurement part is that we are dividing the test and measurement types into 3, respectively 4 different classes. First class is the verification. That is a basic test on the cabling if the wiring is correct. So basically it is a wire map tester, but in today's testers sometimes more nicely. Then you have the qualification tests that determine the transmission capability of links. So we have here the ability to test with a bit error rate test if the links can run with 1 or 10 gigabit. The certification, classical acceptance measurements on links, is the assessment against the standards. Different link definitions are as well available, and a lot of low frequency and high frequency measurements and calculations. Then the 4th class is then the active and troubleshooting, where you can solve Ethernet problems, and you may have standardized transmission tests and probably as well some special tests for troubleshooting or functions included in verifiers and qualifiers. Usually the most certifiers do not have these abilities built in. So verification is supporting only a very few parameters like wiring, sometimes on the bit larger and bit more expensive units as well with length measurements like the Cable Master 600 and 800 and the Cable Master 500. There is usually no documentation for simple devices. So the Cable Master 200, in example, has no ability to store test results, but on the higher end units you can store that, but that is basically a screenshot. The error analysis and localization is then possible if you have a TDR built in, so that you can find as well shorts in the cabling runs. Opens are usually capable of being found as well if you don't have a TDR built in, but for shorts you need a TDR. Testing of active functions in the high-end units is as well something that we more often see today. So the Cable Master 600, 800 have some really nice things built in, like you can ping, you can trace route, you can test for DHCPs and all this other stuff. So this is a fairly good small instrument if you are supporting small networks. If you look for the verification as a correct foundation for the cabling, then you basically look for what is going on. And you can do that with a tester that starts up approximately at 50 euros. And this would be the Cable Master 200. The real benefit on this small unit is it can produce additionally tones. It can additionally find if you have a link that has a split pair problem. We don't go into the very deep today because it is a basic training, but this small tester for 50 euros is doing his job very, very well. Then in the larger units, you have then the passive verification, including lengths, including the wiring diagram, and you can measure as well to shorts, what the Cable Master 200 cannot do because it does not have a length measurement in there. And you have a TDR built in, so you can find the shorts as well. You can address if the tester should show you the diagram for the wiring in T568A or B. We have selected B in this picture, but it did say, okay, this would be a pass because all 4 pairs are present. Everything looks fine so far. They are fairly similar as well. So the tester would say the wiring is correct. The active verification for link speeds, for link connection, for power over Ethernet load tests can be done with these units as well, up to power over Ethernet plus. That means up to a power of approximately 26 watt at the supplied unit, and the supply itself can go up to 30 watts. The qualification testing is testing mainly for applications. So what the unit is doing is it's doing first a signal to noise ratio test. So the noise sources like text, next, echo, noise, ambient noise, they are all combined into the signal to noise ratio. And there are some minimum requirements for different Ethernet speeds that are then put into the unit as well. It is a very quick test, but very often only an evaluation from one end. A second test run may be required, and it does not make any statements about maturity radius, so it does not find out where the noise is coming from. The bit error rate test or packet error rate test is really sending 100 or 100 or 1000 or 10,000 base T about over the physical layer. So we really have signals like you usually have it in transmission at the end. So that is basically what this unit is doing with a bit error rate test. And it is evaluating that against the Ethernet's fault tolerance according to IEEE 802.3. For 1 gigabit in example, there is no allowance for any bit loss inside of 10 seconds. That is a common test, but as well, this test is very much depending on the chipsets that are used in the test device. Additionally, we have this 4 times the charm naming on this unit here. The NetExpert XG combines 4 qualification tests in one. It is determining the correct wiring, it is determining the signal to noise ratio, the bit error rate test, and as well as the delay skew. And that is fairly important for transmission of gigabit and up. So if you are running on gigabit or 2.5, 5 or 10 gigabit, then you need to have this delay skew test as well in there. And that is something that the NetExpert XG is doing as well very fine. The NetExpert XG additionally has some more tests and troubleshooting on active links. So we are capable of doing network tests and diagnostics on copper, on fiber optic, and on Wi-Fi connection. So we have all 3 standard medias that you find today inside of structured cabling. And the active port, link speed, and link status can be done. You can test for power over Ethernet plus, and power over Ethernet plus, or high power over Ethernet that is usually using all 4 pairs then. And it can measure the voltages and the voltage drop under load up to a power of 100 watt. So there is a real large resistor built in that can consume this 100 watt then, so that we can find out how much the voltage drops there. It can do network scans with an overview over devices in the network. It can do a DHCP test, so it is checking if the IP assignment works fine. It can do pings to a single IP or URL address. It can do as well the same on a list of addresses, not at the same time. It is not simultaneously, but it is quasi-simultaneously, because they are then addressed one by each other, and then you get a result at the end. The trace route function for packet tracing and display of the transmission hops works as well if you are connected, in example, with your unit in a network that has an internet connection, so you can check if your packets are reaching to google.com or wherever you want to go. Then we have a link light that is a fairly slow blinking on a link LED on a switch, so you can identify links by using this blink light. It can decode CDP, that is Cisco Discovery Protocol, and LLDP protocols, that is a Logic Link Discovery Protocol, if these are present. We had sometimes customers already asking, hey, my NetExpert doesn't show me the CDP or LLDP protocols. What is going on here? You have sometimes to wait up to 30 seconds or more until all the units are sending these signals out. And the same applies to a VLAN, so virtual local area network detection. And these are usually stripped off on the most switch ports. So if you are connected simply to a switch, it may happen that you don't see the VLAN detection because it is not present anymore on this link at that site. Basically, when you're looking with a mirror port then onto a switch, and you see all this, the information that are going through the switch in total, you will then have a possibility to do this VLAN detection. It will show you all the VLANs then. The test reports of a qualification is more or less as well the wiring, the delay skew, the SNR, and the capability of the transmission. You can store this in the devices, and there's a lot of storage space in there for several thousand test results. And the tests can be stored there as direct PDF report, as a CSV file, as an XML file that is in preparation, and the original TST, the test files. The printout can then be done with an external PC or tablet, and it is basically no special software required, but we have the integration into the export software in preparation in the moment, so there will be a possibility to upload all the test results as well into our e-export software. Don't ask me when. This is a question that I can't answer, that you would be usually product management that you have to ask there. Okay, certification, that is a classic acceptance measurement, and that is a standardized measurement on networks today, especially on larger networks. The smallest network, like a small praxis for an advocate or for a lawyer and for doctors, usually they don't use this acceptance measurement. They use more or less the qualification then. But the larger installations usually have then the testing against the electrical properties of a data link. And these are determined then by low and high frequency measurements and additionally some calculations based on the measured values. The standards today have some limits in there for the specific categories or classes. And if you fulfill this performance from the category or class, it guarantees a problem-free transmission of a wide range of applications. The basic link definitions that we have is usually the permanent links that is tested, but there are some more definitions between two ends of a cabling today that may be as well an end-to-end link in industrial environment, or it may be an MPTL, a modular plug terminated link. That means you have a link on the end is an RJ45 plug that you can directly plug into your receiver. And in examples, this is fairly often used if you are looking for security cameras. You don't want someone to plug out a patch cord on that one. So MPTL links are more and more getting common in security issues. And the number of connectors may vary between 2 connector model from the ISO IEC and EN standards and up to a 6 connector model with 5 segments in the end-to-end link. So there is a lot of different definitions in there. These will be looked after in probably one of the next webinars that we are doing. The standards for copper networks are in the Americas, the ANSI TIA 568.2-D, and international for the cables, we have then IEC standards or EN standards, and there you have a lot of subclasses in there for category 5 shielded and unshielded cables and up to category 8 shielded cables. On category 8, you will not find an unshielded cable any longer because category 8 does not, it is not possible to use an unshielded cable for category 8. So you won't find it there. But up to category 6A, you still find unshielded cables. Category 7 is shielded, category 7A is shielded, what the Americans don't do. Then the components that are classified in the ANSI TIA as well as in the IEC and EN standards. In this case, the IEC and EN standard look fairly similar, and they have all the same numbering as well up to the connectors for category 8.2. Then you have the certification when the cabling is done. And the cabling is then according to the American standards from ANSI TIA 568.2-D. From the ISO IEC, it is the 11801-1. For the EN is the 50173-1 in general, -2 in office, -3 in industry, -4 in homes, -5 in data center, and -6 in distributed building services. But what is sometimes not followed in European countries is that there are as well some installation specifications that the Americans miss completely. And The EN 5174-1 specifies all the installation specs and the quality assurance. -2, the planning and installation in buildings, and -3, the planning and installation outside of buildings. Sorry, this is sometimes because I don't have my presenter here, that sometimes these pages flip when I try to show something with the mouse. The testing is then done according to the American TIA standards 1152-A in Americas. In international standards, it is the IEC 61935-1, and in Europe, it is the 50346. That is the testing of installed cabling, and that describes the performances that the testers have to have. Last but not least, the qualification is based on applications. In example, the IEEE 803BA in example is for 10 gigabit. Then there are some additional standards today that will come into the basic standards as well today out as technical reports. In example, the 11801-9901 is for 40 gigabit and the 9910 is for MPTL links. The cabling standards have evolved over the time from 100 megahertz in the early 90s, 250 megahertz, and towards the end of the 90s, 500 megahertz in 2002, when we found that the class E or category 6 cabling is not capable of transmitting 10 gigabit. Then at the end, the international and European standards, as well as the German standards, had the specifications in there that were all in classes. The only is the Americas that always use categories for the link classes. The 600 and 1000 megahertz class was left out from the Americans, but they decided then at the end, okay, we have 500 megahertz to be used on a category 6A link to transmit 10 gigabit. What do we need to transmit 40 gigabits? And simple calculation, you need 4 times as much frequency. That is a pity that it took that way, because in international standards we were working on transmission with 1200 and 1600 megahertz links, and the Americans made it very simple, this calculation. So we have today category 8 links and class 1 and class 2 links running on 2000 megahertz. We had a tester designed from what we had heard at the time, and the wire expert was first designed for a frequency range of 1600 megahertz. And after this step to 2000, our engineers took approximately a week to find out how we can go higher in frequency without losing quality. So the accuracy is still quite stable. And we found out that we can go up to 2,500 gigahertz in the frequency range without a lot of effort. So we needed to change some parts on the oscillator stages so that we could go up there, and for sure as well change something in the software, because we need new limit lines and all the other stuff. So basically the 2000 megahertz is the frequency today for a category 8 or class 1 and class 2 transmission, but on all three only 30 meters long. So the only application where it makes sense to use it is today in short link applications, like in example, a switch that is sitting in the top of a rack or in the middle of a row or on an end of a row and supports a complete row from there in a data center, not in the office environment. The numbers and values that we measure and that we test and that we calculate out of that one on the tester is a lot of stuff. So we have on the low frequency the wire maps, the direct current loop resistance, and additionally today is the direct current resistance unbalanced within a pair and between pairs. These are the low frequency values that we have. The propagation delay is basically something that will be measured not by DC, but it will be on a low frequency. It is a standard that says, okay, 10 megahertz should be the number. And if you compare that to 2 gigahertz, that is low frequency. Then we have the RF parameters like insertion loss. We have the pair-to-pair next. We have the far-end crosstalk that is not reported as a single value because it would be not comparable depending on the length of the links that you have. And you have the return loss. And from that all, you make a lot of calculations, like in example, From propagation delay, you determine the length. Only informative in international ISO IEC and EN standards. In Americas, you still have the limit of 90 meters in there. The delay skew to make sure that the transmission can be bound together again at the end of the transmission link. All these things that you have transmitted over the 4 pairs must be combined at the end back again. Then you have the pair-to-pair attenuation to crosstalk ratio, ACRN. In former times, it was only ACR. Today, it is ACR based on next. Then you have the pair-to-pair attenuation crosstalk ratio on the far end. That is the ACR that is based on the fixed measurement. And then you subtract from that one the attenuation, and you get then at the end an attenuation to crosstalk ratio, but on the far end. Then you have the power sum quotations for all these power sum ACRN and power sum ACRF. So all these numbers here are combined together, the same as the power sum for the near end crosstalk if you're looking only to the next values. Then there are some optional parameters that are basically not designed to be used in the field. That is the unbalanced attenuation near end, TCL. That is the difference between the balanced signal and the non-balanced signal that you may have on a link, and that can be measured, yes, but there's a measurement that should be done usually in the laboratories of cable manufacturers and component manufacturers. The unbalanced attenuation on the far end as well, the ELTLTC, that is the equal level TCTL that you have then, but that is something as well, same. The coupling attenuation in the field is, as far as I know, and that is something that I have to claim for that one, it is not capable of being measured in the field at all because you have a very complex measurement setup to do that. The alien crosstalk measurements like alien next that we usually do not report, the alien fixed that we usually do not report, similar to the power sum values to all of these above, is something that you can measure with our tester as well, but you would need then 2 pairs of units for that one. On shielded systems, it does not make sense to measure that because the alien crosstalk between 2 shielded cables, between one pair on one cable and to the other pair of another cable, is so small that we cannot measure it with field instruments. Even in laboratories, it is hard to define what the alien crosstalk between cables is if you have shielded cables. On unshielded cables, that is a different issue. You may need that as well, but basically this is done by design of the cable manufacturers and the component manufacturers. So that is something that the influence of an installer is fairly low. We are looking to some of the screens for low frequency parameters. These are usually shown as either a graphic. If you are looking to the wire map, it is colored, and it can be colored for A and B. Then you have a table that is for the resistance as well as for the DC resistance unbalanced values. Then you have some more values and some more screens there, and as well as the lengths and delay values. By the way, the shortest pair that is being measured in this example is a pair with 32.3 meters is the length that the tester will claim. And that is combined between the twist in the pairs and the twist in all 4 pairs, and it is the sheet length of a cable. The RF frequency parameters, the high frequency parameters, that is something that you can get out in graphical format. Usually only on the local unit. We have a combination of 2 screens on both units that we have. We have a local screen that has a white background and a remote screen that has a black background. You can see the results basically in numbers on both sides. You can see the wire map, you can see the distance to faults, everything you can see on both units, but the frequency graphs that we can look into are only visible on the local unit, where they are stored, by the way, and from where we can get these into the software. We have only one sample in this presentation because of the time. We had a limit here in this timing. First it was 45 minutes, now we have a little bit more. And what we want to highlight is that we have a time domain next locator function built in for the parameters next and as well for return loss. So mainly all the faults that you are looking in the high frequency area, can be found with this function very, very easily. For this, we are doing vector measurements inside of the unit, and we can then calculate with a fast Fourier transformation into the time domain and represent it then as a graph. So in this case here, there was obviously something in the middle of the link that affected the next fairly well. It may have been some clamps that someone has put in between two cables, and that may be the reason for that one, but I cannot say that because I have not measured that link myself. Okay, the test reporting is done with eXport software. That is a freely available software that you can download after a registration from our website. So please feel free to download the software, and you then can use that one. There is usually a sample data set with it so that you can see how that looks like. And the reporting is done in a mixture of numbers and of graphs as well. And these graphs are real high resolution graphs, so you can look to that one fairly well. You can get the overview lists out of that one for copper and for fiber mixed as well. You can have coax measurements in there. You may have only some fiber test results. For fiber is usually attenuation measurement, and then you get some numbers out of that one. And you have the ability on fiber testing, and that will be done tomorrow as well, that you can have there the microscope pictures and as well as reporting in there. So that's basically for the moment, and we want to go now for promotions and other seminars. So we have a promotion running in the moment that is still valid until end of May, and we had named it Conquer the Fiber Optics World, but you will find the wire expert as well in there. You will find the net expert in there. You will find the OTDRs in there. So everything that is around copper and fiber testing is promoted in here, and make sure that you make your choice if you wanted to have one of these instruments, and if yes, be a little bit in a hurry because end of May is getting closer. So make sure that you make your claim there. Essentially, we have some more seminars to run. We will do tomorrow on the 12th of May. We will do a fiber optic fundamentals and the cabling standards update. I'm not sure, I think it is next week or so. It's what you do, Konstantin. And yeah, there is another one. So basically the copper fundamentals are done by now. And thank you very much for your attention. And do you have any questions?
Yeah, we have 3 questions actually. One was more a suggestion actually. It would be good to have the relation table between classes and categories in our testers. Well, we have these tables with all the cablings, classes, and versus the applications separately because they can be quite huge and complex.
Yeah. Basically, you can get that table that is that you have seen there. You can get that out of orders for presentation. There is a download area where you can download the following things here from our website. You have the presentation from today as a PDF file. You have the promotion flyer for our promotion, and you have the product catalog as well in there. And at least in the presentation, you will find this table. If you need that extra, just give us a word or drop us a notice. Send us an email to either info.itnetworks@softing.com, or send it to me or send it to anyone else you know here, and we can get this slide extra for you to print it out and put it into the bag of your tester. I have one other thing that I would like to promote at this site at this moment. That is our handbook of cable testing. That is a small A5 handbook that is very, very small and handsome. You can put that into the bag of your tester as well. And if you need some, drop us a notice. We have lots of them, not thousands anymore in the moment. I just heard that we are running short on the German ones, but I think the English ones, we still have some hundreds available. So if you need some of these handbooks, drop us a notice, give us a word, and we will send it. We will be happy to send it to you.
The next question was, do I have to be consider something special when I have to test cables with cable sharing?
Oh, cable sharing is basically not any longer allowed from the standards. So basically, you should not find any cable sharing in new installations. You can do measurements on cable sharing as well, of course. Yes, that is possible. You can put in there either a standardized 1, 2, 3, 6 wire for the cabling, for the cable itself, and then you may be able to use it for cable sharing as well. And if you may have the situation that you do not have 1, 2, 3, 6, you can always create your own cable, and you can define if you want to have 1, 2, and 7, 8 as the pairs to transmit the signals, or 1, 2, and 4, 5, or 4, 5, and 7, 8. Whatever you want as a combination is possible there. But that would be going much too deep today now.
Okay, the last question was, can I test with a NetExpert across switches, basically?
Basically, yes, if you do the network detection, you can do that. If you are doing a standard qualification test, it will not run over a switch. So basically, you can test in network detection what you find into your network. So what you already have as an active component in your network. That is possible, of course, yeah.
That's all questions up to now. Let's.
Okay.
No, not more questions. Okay, thank you.
Yeah, then thank you very much for your attention. And if you still want to get this stuff, please make sure that you grab the download area and that you get it done from there. And that's it for today. And many thanks and thank you very much. But we leave it still open for just a moment, because you can then download your stuff that you want to have from the sidebar.